We'll be discussing now combustion air and flue gas systems. It has fans, air preheater, scrubbers. It also has dust collectors, electrostatic precipitors and back filters and stack liners where you can have fire hazard, and bulk anhydrous ammonia tank storage has explosive rating of 16 to 25%, high ignition temperature of 1200 degree Fahrenheit and low heat release, specific gravity of 0.6, highly water soluble and unlikely combustion explosion. All kind of things are related to fire hazard. And combustion turbine, it has fire hazard, fuels and lubricant, hot surfaces, explosion hazard, operational practices, peaking units, remote operation. Whereas fire protection side, you have water suppression system, carbon dioxide, halon or alternate water mist, dry chemical, fire detection, thermal flame, interlocks. Alternative opportunity fuel plants, where types of facilities, you have biomass, mass burn, refuse derived fuel, scrap rubber tires, landfill gas, methane based farm animals waste or sewage plant, major hazards, explosive material in fuel, large fuel piles with poor accessibility, difficult housekeeping and maintenance, dust generation, hydraulic and lubricating oils. Fuel cell characteristics and type, PAFC, MCFC, PEFC and SOFC. So SOFC is solid oxide fuel cell, PEFC is proton exchange membrane fuel cell, MCFC molten carbonate fuel cell, and PAFC phosphoric acid fuel cell. Potential application, PAFC is dispersed electric on-site cogeneration and output megawatt is 1 to 10 and 0.1 to 1, 0.2 to 1, and efficiency electrical and cogeneration it is 41%, 40% or 80%. Temperature is 200 degrees centigrade. Whereas MCFC, which has potential application, dispersed electric on-site cogeneration central power, output 1 to 10, 0.25 to 1, 100 and above. Efficiency 50 to 55%, 45% and 50 to 60%. For different rating of output power, of 1 to 10, your efficiency is 50 to 55%. For 0.25 to 1, your efficiency is 45%. And for output power of 100 and above, efficiency is 50 to 60%. And temperature for all of this, it goes up to 650 degrees centigrade, which is very high, and that's why it's a molten carbon fuel cell. For PFC, proton exchange fuel cell, its potential application is on-site electric, and output is 0.25 megawatt, and efficiency, which is 40+%, and temperature goes up to 80 degrees centigrade. Solid oxide fuel cell, SOFC, potential application, dispersed electric central power, and dispersed electric has an output of 1 to 10, whereas central power has a 50 and above. And efficiency wise, 1 to 10 has an efficiency of 50%, and 50 and above has 50%, and temperature it goes up to 1000 degrees centigrade. And here is picture how fuel cell looks like. So you have one side is anode, another side is cathode, and you pass the oxygen and hydrogen in the other sides, and they mix up, they produce electricity through the wires. And here is diagram related to that. On the chemistry, you are seeing that you have anode, you have cathode. Anode side you get the fuel, hydrogen. On the cathode side you get oxygen, and then hydrogen ion, it passes through the membrane and it mixes with oxygen here, and you get the water on the cathode side, and you produce electricity You can go through the wires. Okay, so this is giving you an idea about fuel cell, how it works, the chemistry behind, and all this. Okay, next is hydroelectric plants. This time, okay, you preserve the water on a dam, then you open the dam and then produce the electricity. Okay, and it is showing here. Let me. So this is a picture for a hydroelectric plant, how it look like. So water from one side with height higher than the other side, it passes through turbine, produce electricity here on this area. So let me zoom in to that. Okay, so you have water you collect here and it goes through this area. You put certain kind of strainer, okay, trash rack, so that no trash can go there. And then water flows through it. Okay, this is the dam we call, and this area we call penstock. This area that take the water, then it hit the turbine here. It produce electricity. As soon as turbine, you know that it connected with the shaft with generator. As turbine blade rotates, turbine rotates, generator rotates, and it produce electricity. Okay, and we can get that one, bring it to neighborhood where we want to use the electricity. Whereas the water, excess of that, it actually goes there, water discharge. Okay, so you get an idea about hydroelectric power plants. Is very simple idea. So fire hazard here is generator windings, cables area, cable shafts, oil insulated cable, location of transformers, and operational practices. Fire protection side, you can have water suppression system, gaseous system, fire detection system, manual fire protection. Whereas life safety side, access and egress and ventilation side. Competition or deregulation, downsizing. Okay, you can have declining operating experience, reducing maintenance activities, fire brigade manning. Whereas stretching operating conditions to improve efficiency by using different fuel, revised air fuel, new scrubber, new burner, etc. Aging workforce. You have prime prevention factor for major fire, 36.5% human element, 23.1% for process, 16.9% for yard or exposure, 11.5% for protective safety devices, and 12% for weather and miscellaneous. Okay, so this is talking about the competition and deregulation side.